Today we're going to study about electrolysis. Electrolysis is the breakdown of an ionic compound into molten or in aqueous solution by use of electricity. When a molten ionic compound is electrolyzed, then a metal is formed at the cathode and non-metal at the anode. Now, ionic substance contains charged particles and we call them as ions. For example, lead bromide contains positively charged lead ions, and negatively charged bromide ions. So electrolysis is, again I repeat, is a process by which ionic substance are decomposed, broken down into simpler substance when electric current is passed through it. But another important thing is electricity we can define as the flow of electrons or ions. So for electrolysis to work, the compound must contain ions. So ions compound which are ionic compound, they can follow the process of electrolysis, but covalent compounds cannot act as electrolyte because they contain neutral atoms. The ions must be free to move, which is possible when an ionic substance is dissolved in water or it is melted. For example, again here what we see is we are using molten lead bromide. The lead bromide is broken down to form lead and bromine in this example. So we'll see clearly lead bromide is broken down into lead and bromine. Now this is what happens during electrolysis. The positively charged ion move to the negative electrode. Here you will see the positive charged ion is lead Pb2 plus, that's the cation. So the positively charged ion move to the negative electrode, that's the cathode, during electrolysis. They receive electrons. So when they receive electrons or when they gain electrons, we call it as reduction. So they receive electrons and are reduced. So here we see again in the equation lead ions, we'll see that lead ions Pb2 plus will gain electrons and form lead, and that will be formed at the cathode, and we say it is reduced. And in the anode, the negatively charged ion move to the positive electrode during electrolysis, and they lose electrons and are oxidized. So here we see that the non-metal ions, usually it's a non-metal ion, so bromine is a non-metal ion, it's an anion, so it will go to the positive electrode, that is the anode here over here, and then they will lose electron to form neutral atom or molecules, and we call that as oxidation, and the substance is oxidized. So this is how the whole process takes place, and this is the equation. Here bromine ion will actually, what will it do? It will lose 2 electrons and form bromine gas at the anode. So this, again very important to know, is this is taking place when we are using molten substance and we do the process of electrolysis. So electrolysis can take place when it is a molten substance or it is a solution. So today we are, in this lesson, we are more concentrating into molten substance. Another example, but now some more example and some half equation we learn, and then we will go to one more example. So here we can take the example of, let's use potassium. Let's use a thinner, yeah. So we can use potassium iodide. So potassium iodide, example number 1, potassium, Potassium, potassium iodide, DIDE, and its formula is Ki. So this is the actually the electrolyte. Now let's see how the decomposition of the product is there. So decomposition of potassium will take place and iodine will take place. The other substance will be iodine. Now at the cathode, this is important, at the cathode, remember what is taking place at the cathode? we see what process is taking at the cathode. This is the cathode, so reduction is taking place and gain of electron is taking place. So here K plus, that's the ion, plus electron, that means it will gain electron and will form potassium metal. Where it will form? At the cathode. And what reaction will take place at the anode? Here iodine, that is, if we balance it, it is iodine, let's make it 2I, will give you I2 plus 2 electrons. So what is taking place at the anode? When negative non-metal anion arrive at the positive electrode, the anode, they lose electrons. So here what is happening is they lose electron, and that is known as oxidation, and it will form iodine. Where will it form iodine? It will form iodine at the anode. So this is one example. Another example, let's do something similar. Let's talk about copper. COPPER, copper to bromide, BROMIDE. What's the formula of copper to bromide? CuBr2. So that's copper bromide. So at the cathode, reaction that is taking place at the cathode. What is taking place at the cathode? Copper ions will go at the cathode and it will gain 2 electrons and form copper metal. And at the anode, what will take place at the anode? The bromine ion, Br minus, will go there and go at the anode and form bromine. How will it form? It will 2 minus. How will it form bromine? It will form bromine by losing electrons. And what do we call that? As oxidation. So oxidation will take place at the anode. Oxidation will take place at the anode. And at the cathode, what will take place? Reduction. So these are 2 examples. We can do more examples, and let's concentrate into another example, and that is example of a very important metal, that is extraction of aluminium. EXTRAC, extracting aluminium. ALUMINIUM. So if you look at it, now look at this diagram. Before we look at the diagram, we should know a few things. Aluminium is actually the most abundant metal on earth, and in the past it was very expensive. Why? Because large amount of electricity was used in extraction of aluminium. But since we found out cryolite, that is Na3Al(F6), we have decreased the melting point of aluminium and less electricity is used. Therefore, it has become cheaper. So aluminium ore is actually called, what do we call the aluminium ore? That is bauxite ore, and the formula will be Al2O3, that is bauxite, not extraction or extracting aluminium from aluminium oxide. So the bauxite ore is purified, and we what we do is we yield a white powder from it, aluminium oxide. It's also known as alumina, from which aluminium can be extracted. The extraction is done again by electrolysis. So the first thing that we do is aluminium oxide should be melted so that electricity can pass through it. We can't do it through solid aluminium oxide. It has to be melted, and aluminium oxide has a very high melting point, that is nearly 2000 degrees Celsius, and it's very expensive. So what do? We dissolve it in molten cryolite, Oh, sorry, instead what we do is it is dissolved in molten cryolite and aluminium compound with a lower melting point. So this cryolite over here is Na3Alf6. So it has a lower melting point than aluminium oxide. So the use of this molten cryolite as a solvent reduces some of the energy cost involved in extracting aluminium by allowing the ions in aluminium oxide to move freely at a lower temperature. So that is very important. So in this diagram what we see is aluminium oxide electrolysis. This is the electrolysis cell that is taking place. Both the negative electrode, you will see the carbon electrode is this, these are the positive one, the anode is the, it's made of carbon graphite, and also the negative, the carbon lining cathode is made of graphite. So both of them are made of graphite, which is a, we all know is a form of carbon, allotrope of carbon. So over here aluminium ion receives electron at the negative electron and are reduced to aluminium atoms. So we can write down at cathode, CATHODE. So what reaction is taking at the cathode? So aluminium ions received electrons. So we can write down Al3 plus 3 electrons. What will it do? At the negative electrode, aluminium ion receive electrons at the negative electrode and are reduced to aluminium atoms. So it will become aluminium atoms. So the molten aluminium, here we see at over here, we'll see it comes down. The molten aluminium sinks to the bottom of the cell where it is so from the bottom we can take it out. So we'll get molten aluminium from the bottom, collects at the bottom. Now what is left is the oxygen part. So the oxide ions here at the, we can write down at the anode, THE at the anode. Now oxide ions lose electrons at the positive electrodes and are oxidized to oxygen gas. So here it will be 2O2 minus will give you O2 plus 4 electrons. That is oxidation is taking place. Here what is taking place is reduction, DUCTION. Why reduction is taking place? Because we can see there is gain of electron. There is gain of electron. And over here what is taking place? Oxidation. Oxidation is taking place. So what is it? Loss of electrons. So remember that. So this oxygen reacts with the carbon of the positive electrode. So this will react with the carbon over here, the carbon rods over here, what we see over here. So the oxygen reacts with the carbon of the positive electrode, forming carbon dioxide. So they gradually burn away. As a result, the positive electrode has to be replaced frequently. So here this electrodes have to be replaced frequently because oxygen will react with carbon rods and form carbon dioxide and goes away. So this is how we can extract we can say aluminium from through the process, molten aluminium, through the process of we can say through the process of electrolysis, and cryolite plays a very important role. So these are two examples where we used electrolysis in molten state. First was what we did was on lead bromide, and the second one we did extracting aluminium from bauxite ore, that is Al2O3. I hope you have understood it, student. You can write down some comments at the bottom if you want, if you haven't understood, if you want to ask question. And please subscribe if you really like my video lessons, and please share with your friends. Thank you, students.